Sienna. So this is just to help with those that second question in the homework and then the difference between the domain and range of a function. So just have the question next to you. Just so because I'm not going to write everything down when I read it, but it basically says the straight line y is equal to 2x plus 1 intersects the curve of y equals x squared plus 3x minus 4 at points A and B. Okay, so this looks a little bit tough, but actually it's exactly what you just did in the previous simultaneous equation. It's a very similar concept to simultaneous equations. So if I would draw the graphs, so y equals 2x plus 1 looks something like that. Then y equals x squared plus 3x minus 4 looks something like that. Okay, so they intersect at 2 points. Intersecting means they touch, they cross each other. So it's here and here they intersect. So over here, at points A and point B. Now, how do we find these points? Well, at these points, the graphs are the same value, right? Because y1, so I'm just going to call this y1 and y2. y1 is equal to y2 because they're exactly the same point on the graph. Same as here, exactly the same point of the graph. So how do we find the points A and B? Just set the graphs equal to each other. So set y1 equal to y2 and set 2x plus 1 equal to x squared plus 3x minus 4. Then you get x squared minus x plus x minus 5 is equal to 0. And then you just factorize this as you would normally. Cool. So that's how you do that one. Just give that a spin. I'm not going to finish the factorizing here, but here's just the concept. And if you need more help with the concept, just let me know. Okay. So now you say, I also don't know the difference between the domain and range for a function. Okay. So the domain of a function is the possible set of input values, and the range is the possible set of output values. Okay, so let me explain a bit more. So let's go to domain. So if we have a function y is equal to 2x plus 3, what is our input? We are inputting x into our function to get y. So maybe it's easier if I illustrate instead of y is equal to 2x plus 3, if I go fx is equal to 2x plus 3. X is our input. So we input an x, it goes into this function, 2x plus 3, to give us our output. So f of 2 is equal to 2 times 2, because now where the x is, there's a 2, so we replace this x with a 2, plus 3 equals 7. Okay, so your domain is the set of values that this x can take on. Right? So let's say I have a function f of x is equal to 2x plus 3. Okay? Is equal to 2x plus 3 for 0 less than or equal to x less than or equal to 3. So x can only take on values between 0 and 3. So like 0, 0 0.1, 1, 2, 2.9, 2.99, and 3. Like those are just examples of values. We could take on any values in this domain. So that's what the domain of a function is. Now, the range of a function is the set of output values, so the possible values that f of x can take on. So if f is equal to 2, we know f of x takes on a value of 7, right? So f of x is the set of possible values. The range is the set of possible values f of x can take on. So let's do this example here. So they've given us the domain, Now the range, draw a rough sketch of the graph. So the graph looks something like that. But we know x can only take on values between 0 and 3. So 0 and 3. So we don't have to worry about this part of the graph when we're looking at the range. Okay. So we could see from this graph, that's why it's always helpful to draw a sketch, that this is the minimum value and this is the maximum value, right? Because the graph is going in an upwards direction, it's increasing. So to find the range, we input in our smallest value. So f of 0 is equal to 3, and f of 3 is equal to 2x plus 3. Yeah, so 2 times 3 plus 3 is equal to 9. So our range of our function is 3 less than or equal to f of x less than or equal to 9. So that's why it's very important to draw your graph so you could see which values are important to plug in to your function to see its range. So if I have a function like that just looks like this, right? Let me draw it a bit better. The range is our possible y values, right? So I could see here, let's say, let me just rub it up nicely. Use an eraser. So let's say they've told us the graph is defined on -3 to 3. So that's the range. That's the domain, right? Because this is our x values. Our x values care about the x values are the domain. So to find the range, here you wouldn't plug in -3 and 3 because these are going to be the same values, right? To get the range of all the possible y values, this is the maximum, right? And this is the minimum. So we would plug in in this case it's 0, we'd plug in f of 0 and f of 3 to get the range, or f of 0 and f of -3 to get the range, because -3 and 3 are the same. Will have the same value based on this graph. So you just need to draw the graph and then to get a bit of context about how to answer the question.